Okay, first speaker is actually one of our group members, Ryo, and he's talking about Twin Meander Coil, please.
Hi, everyone. My name is Ryo from Tokyo University. So today we'd like to talk about 2 years old project named Twin Meander Coil, which can create a body-scale wireless networking for on-body sensors. And smartwatch or smart glasses are the famous wearable device. And besides these wearable devices, on-body sensors, which can naturally attach to the body or clothing, have gained attention. This is because on-body sensor can monitor user activity or biosignal continuously or ubiquitously. However, it is still challenging to deploy the on-body sensor to the real world. The main reason is the wiring on the skin. So because on-body sensor needs some electric connection, we need to a bunch of wiring on the skin. So, but such wiring disturbs user movement and impair usability or wearability. So that's why we focus on the daily clothing. Because the clothing exists near the on-body sensor, we wonder what if we could wirelessly monitor the on-body sensor, so battery-free, wireless, and on-body sensor by daily clothing. If so, we can release the wiring or even the batteries through, from the on-body sensors. Of course, some prior work tried to achieve this goal. So textile antenna and coil are the famous approach. However, these approaches must be narrow. So this approach must support narrow range because the body scale, so large antenna and coil interact with the deep tissue in the body. That's why we cannot extend the wireless readout range. So here we present a twin meander coil, which can enable a body scale wireless readout of on-body sensors. So this consists of textile reader coil, and this green one is a readout board and battery-free on-body sensor coils. And the textile coil is stretchable and washable. And also, the on-body battery-free sensor coil supports a barrier signal, so can monitor barrier signal like ID touch, pressure, or rotate. And let me explain the working principle of the twin meander coil. So this consists of the on-body sensor coil and the textile reader coil. And when the sensor coil is placed near the body, so near the clothing, the reader coil and sensor coil connect with inductive coupling. And through the inductive coupling, the sensor coil can send its on-body sensor value as like this, so peak. So the peak appears in the reader coil, and this peak means the resonant frequency of the sensor coil, and which can be determined by the sensor's inductance and capacitance. So by changing the resonant frequency using like capacitive touch sensor or capacitive bios sensor, so like variable capacitor, the sensor coil can transmit its on-body sensor value passively to the reader coil. And reader coil can detect the change of the on-body sensor as a peak shift. Then here, based on this technique, so we propose a twin meander coil, a body scale wireless net sensor readout. And twin meander coil consists of a meander coil, so which can cover around the body. And also, we use a readout board, a special readout board named bridge circuit, so which can monitor the small and multiple on-body sensors. Meander coil is simple. It changes its winding direction for each turn. And with this unique winding pattern, we can confine and generate a strong inductive field around the skin or wire edge. And typically, on-body sensor are placed near the skin. So the meander coil is so compatible on the placement on the on-body sensor coil. So that's why we don't use a standard helical coil, but instead we use meander coil and extend the coil area up the body scale. Also, we use a sensitive readout circuit called bridge circuit. Because the peak appear in the readout coil is very small, so that's why we need some sensitive readout circuit. And here we focus on the bridge circuit. But the bridge circuit requires the symmetric circuit structure. So that's why we split a single meander coil into the two identical meander coils and connect them. With this twin meander coil structure, the bridge circuit can work properly, so amplify the small peak. And this is the fabrication process. So here we use a knitting machine, so industrial knitting machine, to create a body scale textile reader coil into the clothing and automatically. Although we need some manual tasks like attaching the chip capacitor or attaching magnet, but most process is done automatically. And this is the prototype. And here I bring my prototype. So this is the latest one. And yeah, this one supports so up to 2 over 3 on-body sensor coil. And the readout distance is 1 centimeter. So you need 1 centimeter. And of course, this is washable. So if you are interested, you can wash it. I don't need any more, so you can wash it. And this is the working principle. So as you can see, the readout, there are a peak appear in the readout's output. And there are so 3 peaks. And by changing the resonant frequency of the sensor coil, so by like here, capacitive touch sensor, the peak shift in the readout output. And here I show the simple application. So first, the meander coil, so the twin meander coil can detect the position around the clothing, so near the clothing. So here we use an ID sensor coil, so which has no variable capacitor or no inductance. So that's no variable inductance. That's why it has unique resonant frequency. So by attaching the different ID sensor coil to the different place, we can monitor the different position. Also, by attaching the 2 pressure sensor coil, we can monitor the user posture. So by combining the position detection and posture monitoring, we can provide a position-specific or position-aware posture monitoring, like bending in the chair or sleeping in the bed. And finally, let me explain the variable sensor number. So I don't explain the detail, but user motion so impair the symmetry of the twin meander coil. That's why we need to limit our on-body sensor number. And here, we limit the number is 2 over 3. And this project was done 2 years ago, so we almost finished our future work. But for like example, adding charging function, so wireless charging function, or supporting both charging and readout, so this case, so readout function. So let me summarize my work. So here we use a twin meander coil and machine knit. And with this combination, we can provide an automatic fabrication of body scale wireless sensing platform for on-body sensor. So that's all.
Okay, thank you very much. Any questions?
Oh, sorry.
Oh, sorry. Now can you hear me, right? Okay. Can you like go back your slides to the advantages that compared with narrow work? Yeah.
Narrow, so
Yeah.
antenna or coil.
Yeah, and the narrow antenna. So what is this design? The advantage of this design compared with a narrow antenna design? Yeah. Can you explain more? Thank you.
So we can change the sensor position freely, or so narrow means we need to fix our sensor position but depending on the user style or application scenario, we need to change the position of on-body sensor. That's why wide or wide readout distance area is necessary.
So in that way, you can have a more flexible or more larger degree
Yeah.
of freedom in
Freedom.
in terms of place the sensor in different place, right?
Yes, right.
Okay, okay, thank you.
Yeah, thank you for the talk. It was really interesting. I saw that you used maybe like a VNA for your reader, right? And that's where you see the resonance peaks.
Yes, right. So
Oh.
we measure the frequency response using VNA. It's kind of VNA.
Yeah, so any thoughts on maybe doing it with like some kind of commercial systems which use this 10 to 15 megahertz frequency range?
Yeah.
Like maybe some kind of NFC reader if possible?
Yes, possible. So here we use the 113, so NFC frequency band. And one of my future works, so already done, but we added the NFC function to this one. So we can monitor the NFC sensor coil like temperature or IMU or bending sensor.
And NFC provides the different signal amplitudes for different frequencies, so you can find the notch.
Yeah, but NFC is basically based on the time division, but my approach is frequency division.
I see. Okay, thank you.
Okay, thank you very much for questions. So we need to move to the next speakers. So if you have any further questions, please use Fuba app, mobile app, and you can find the Q&A button, and authors can check the questions and answer. Okay, the second talk is about WETRA, monitoring diaper wetness with wireless signals, and the presenter is Manshui, please.
Good afternoon, everyone. This is Xuemeng. I'm excited to share with you our work on WETRA. So why we are interested in this topic?